Good morning and welcome to your first lesson in functions. What are they and how do we use them in mathematics? Now today we're going to start with a basic introduction of what a function is and how to use them. What a function is, the basic definition, is a rule or equation in which every input there is only one output. Now we have seen these before. Many times we will refer to a function as an XY table. Now, when we talked about this type of function before, we talked about not only x and y, we discussed it as finding our slope. In this case would be a change of 2 over a change of 1, as well as finding our y-intercept. In this case, we could rewrite this function in slope-intercept form as y equals 2x plus 2. Now, what part of our function here is our input and our output? Our input would technically be our x value, whereas our output would then be our y value. We use whatever we are plugging in. Our input x will give us, when we use our function here, an output of y. Now we've also called these functions x, y, input, output, as something completely different, however, has the same meaning. You may remember before about domain and range. Domain is going to represent our input, our x value, whereas range will be talking about our y value, our output. We've also seen functions come across, as we talked about yesterday, that n side. And there is a new way to show the output side. Well, once again, our n is our input, or our x value. Our output is going to be something we call an f of n. What this stands for is a function of whatever our input is. In this case, it was n. Lastly, the last way that we will show a function is using our x value again as our input, where our output is an f of x, our function of our, of our input x. What do they mean? X is our input, which is our n, which is our domain, which once again is x. Our output is our y value, our range, our f of n, our function of n, our f of x, our function of x. All of those terms, you notice on the tables, are in the exact same place. And all those terms mean the exact same thing. That is what a function is. Now, how do we use the function in our table problem? When we looked at this before, we took a look at the people on the ends. How many people were always there that we were adding at the end of this problem? We were always adding 2 people. Now, where is this in our function? It's 2 places. One in our rule is this plus 2. This is something we will call a constant. What the constant means, it never changes. What value is that in our table? We have called this 0, 2, our y-intercept, or as we also call it, our b. In this case, that was that coordinate 0, 2. That is our constant. It never changes in our function. In that case, we just need to label it as plus 2. Furthermore, if we were counting the people that we added per table, we added, for every table we added 2 extra people. Now, where is that in our equation? That is our 2n. What I like to call our 2n is our rate. Another word for rate is this. First of all, our rate does change as well as we called it when we were using slope-intercept form, our slope. In this case, we can find our slope by finding the change in our f of n, our output or our y side, to be 2 for every one table that we added. In this case, we would get the same function, that 2n, 2 times however many tables, plus the 2 people on the outside. That's how we use a function. If we know how to find slope-intercept form and how to use slope-intercept form, then we know how to find the rule in a function. Now, there are many times when we have a function up here in which you will be asked to find something. Typically, they call it one of two things. Find the nth term and find n, in this case it was n tables, find n people. Those are two separate ways to say one thing. What is the rule? Or, as we are now going to call it, what is the function? When we are saying find the nth term, solve for n tables, n people, we are once again asking for what is the rule, or the terminology that we will now use is what is the function. How do we use functions in real life? In this case, I've given you a word problem in which I would like you to do several things. First, you are going to use the word problem in order to fill out the table. Following the word problem and filling out the table, you are going to figure out what is the rule of this function. Now, what you will do, first we will decipher this problem. We are going to look for Jen, who has $5 in her savings account. And every week she is saving $3 to be put into her account. After 50 weeks, how much money will she have? So, following the table, what you are then going to ask yourself is, how much money will she have after 50 weeks? And what is the function? In this case, we are going to use x and f of x. So your answer for your function should have an f of x is equal to however many x. Pause the video now to work on this individually. When you are done, unpause the video so that you may check your answers. Do this now. If you follow this correctly, you would have noticed that this $5 that is already in her account is a flat rate. It is a constant, is that word that we used before. It doesn't change, meaning that $5 must be in her account after 0 weeks. That, in fact, that 0.5 is our y-intercept. Now, the $3 she saves every week, the $3 every week is her rate, or, as we also know it as, a slope, meaning every week that we add up here, she's adding $3 to her account, which in this case, we would simply add 5 and 3 and get, after 1 week, she has $8. 2 weeks would give her $11. 3 weeks, we would continuously add this 3 to get $14, $17, and $20. Now the question is, what is the function? Well, we simply need to look at what is our constant, what never changes, and what is our rate. Well, our rate was right up here, $3 per week. In this case, the weeks were our x value. So we had $3 times x, the number of weeks. Because we don't know how many weeks we're going to continue this for, we would have it as this x value. And what was the constant? Our constant, or our y-intercept was at 0, 5. So after all of this, we are still adding $5. Your function, in fact, or your rule, was still that f of x equals 3x plus 5. How do we use this for 50 weeks? We simply would substitute 50 in for x, meaning we would have 3 times 50 plus 5. Continuing further, our f of 50, our function at 50 would have 3 times 50, which is 150, plus 5. And thus our final answer, after 50 weeks, she would have $155 in her account. Now how about graphing? In this graphing section, we're going to look at, is it a function or not, just looking at the graph. First, what we are going to do, we have written up here in slope-intercept form the exact same function that you have completed in the prior problem. In this case, this 3 would be our slope, that 3 over 1. Our y-intercept, the 5, as we talked about, would be that 0, 5. What you are going to do now is you are going to graph this line. Pause the video now and unpause after you've graphed the line to check your solution. If you graph this correctly, you would have come up to your y-intercept of 0, 5, and you would have had a rise, a vertical rise of 3, and to the right 1. From our y-intercept, we also could have gone down 3 and to the left 1. You notice here, you have a straight line. Now what we are going to do, there is a way to check if this line is a function. It is something that we call the vertical line test. And what that means is we are going to drag a vertical line. And in my case, I'm going to drag this red vertical line directly across the line that I just drew, this orange line. As you notice, is there any place where this line, my red line, touches the orange line in 2 different spots? The answer here is no, it doesn't. It's only one spot. In this case, it would be right on the y-intercept. In this case, it would simply be up here at 8, 1. This, in case, would mean it is a function. And now we're going to use our vertical line test in order to see if the following graphs are functions. What you will do now, you will drag your pencil, a vertical pencil, across the screen to test whether these are functions or not. Pause the video so you have time to do this. Once you have written down if they are functions or not, unpause the video to check your answers. The following are your answers for whether it is a function or not a function. Every function up here, every one, with the exception of number 3 and number 4, were functions. The reason being, the vertical line test in number 3 crosses our red function, or what we were claiming to be a function, in 2 different spots. And it does this in multiple points. Thus, it is not a function. As in number 4, this one crosses not only in 2 points, but actually 3 points. Thus, it is not a function as well. Lastly, we are going to look at functions in a table. Is it a function or not a function? In this graph, we also have our table. How do I know this is not a function just by looking at the table? Well, we go to our definition, and for every input, there is only one output. So what we are going to look at is, in this table, my input is my x side. As I look in this table, I see 2 come up twice. However, 2 has 2 completely different outputs. By definition, this means it is not a function. Also, I look and see when x is 3, y is 2 different values. Once again, by definition, this is not a function. The 3 problems below, you are now going to test if they are a function or not.